So I give another example for the matrix multiplication because that's very important. That's why I want to make it more clear. I have matrix A. My matrix A is 2, 1, 3, 0, 0, and 4. I have matrix B. So my matrix B must have 2 rows because here is 3 by 2. This must be 2 by something. So we're having a 3, 5, 7, 1, 2, 0. So this is my 2 by 3. So I can just multiply them. So when I multiply them, I get here AB. So I write my A. My A is 2, 1, 3, 0, 0, 4. And my B is 3, 5, 7, 1, 2, 0. We multiply them. My first row, multiply first column. This here is 2 multiplied with 3 is 6. 1 multiplied 1 is 1. Then first row, second column, we get 2 multiplied 5, 10, plus 1 multiplied by 2 is 2. Then first row with third column, we get here 14 plus 0. Then I take second row, multiply with the first column, is 9 plus 0. Second row, multiply second column, 15 plus 0. Second row, multiply third column, we get here 21 plus 0. Then we have in the last row, first column, we have 0 plus 4. Then this last row with third column, second column, we get here 0 plus 8. Last row with third column, we get here 0 plus 0. We get here a matrix that is equal to 7. We get here 12. We get here 14. And here we get here 9. We get here 9. We get here 15. And we get here 21. So the last one is 4, 8, and 0. 4, 8, and 0. You can see here, we get the matrix 3 by 3. So these are the ideas that we can multiply the two matrices A and B. We're moving to the next idea, that is the inverse of a matrix. We're going to discuss inverse of matrix. Inverse of a matrix. We start from 2 by 2 and then we extend it to any size. I take a matrix A. So my matrix A is having the elements A, B, C, and D. I just write the formula for finding inverse of A. My inverse of A is equal to I multiply this A and D, and then I multiply B and C, and we are having here, we interchange these two. This become D and this become A. I multiply here by minus, get minus B and minus C, and I say this is my inverse. Here we say this AD minus CB is not equal to 0, because when it is 0 we can't divide by this, so this must not be equal to 0. So we are having here a property of the inverse that when we multiply A with A inverse, we get here identity matrix. So as we say, the way we are multiplying is important, right and left, but here this is equal to same. For the inverse, we multiply from the left or we multiply from the right, we must get the identity matrix, because inverse has the property, when the inverse, for example 5, where inverse of 5 is 1 upon 5, multiply, we get here 1. Similarly, we have matrix A, and we take the inverse of the matrix, we multiply it, we get here equal to the identity matrix, not 1, not the identity, it's not 1 upon A, very careful, it's a matrix. So we can just have an example, and I show you with the help of example, where A, 3, 2, 4, 5. This is my matrix A. I want to find the inverse. Find A inverse. So I find here AD minus BC. My AD minus CB is equal to 15 minus 8 is equal to 7 is not equal to 0. That means we can find the inverse. Then I can say my A inverse is equal to 1 over 7. Then I interchange these two. I get here 5. I get here 3. Multiply minus. I get minus 2. I get here minus 4. So this is my inverse of matrix A. So I want to check here the property as I was discussing. When we multiply this A by A inverse, we must get the value of this matrix is equal to identity matrix. We look for this property, and we can just show you that this property holds when we're going to multiply it. I just want to write the property. My K is a scalar, my A is a matrix, and my B a matrix. I can say I can write K anywhere I like. I can write KA, then multiply by B, or I can write here A multiply with KB. So we can rewrite A anywhere we like. So I just use this property, and also I want to prove that A inverse A is equal to I. So my A inverse is 1 upon 7, and I am having this A inverse is 5 minus 2, 5 minus 2, and then we're having here minus 4 and 3. And we multiply here, this is my A inverse. I'm writing here this as is into A. My A is 3, 2, 4, 5. 3, 2, 4, 5. So I'm writing here this is my A inverse. So I multiply them. I get here 1 upon 7 out. First row with the first column, first row with the first column. We get 15 minus 8. First row with the second column, 10 minus 10. Second row with the first column, minus 12 plus 12. Second row with the second column, we get here 8 plus 15. So when we solve this one, you can see what we're going to get here, 1 upon 7. And we get here 7, we get here 0, we get here 0, we get here 7. We multiply 1 by 7, each entry, we get here 1, 0, 0, 1. And that's our I. So this is one part. Second part is that we just take here our A and we multiply by this by A inverse. We have multiply inverse by A. Now we take here A and multiply by A inverse. So my A is equal to 3, 2, 4, 5. And my A inverse is 1 upon 7. I get here 5, 3, minus 2, and minus 4. So as we say, K is just 1 by scalar, we can write anywhere we like. We write it outside, we get 1 upon 7. I'm having here 3, 2, 4, 5, multiply by 5 minus 2, minus 4 and 3. So we get here 1 upon 7 is out. And we get here 15 minus 8. Then we get here minus 6 plus 6. Then we're having 20 minus 20. Multiply, you get minus 8 plus 15. We simplify this one. We get here 1 upon 7. Get here 7, 0, 0, 7. Multiply 1 by 7, scalar, multiply each entry with this one. We get 7 upon 7 is equal to 1. And then we get here 0, 0, and 1. And that's my I. So I can write my property, which I mentioned that this is the property we are going to discuss. That's A inverse A is equal to A inverse is equal to I. So the property of the inverse of the matrix.